Welcome everyone to today's Glass Academy webinar. We're delighted to have you here with us to what promises to be an enlightening session on high-rise building facades, safety by design. As our cities race towards skies, high-rise buildings have become synonymous with modern living, symbolizing progress, innovation, and the efficient use of space. However, with this vertical growth comes the critical responsibility of ensuring safety, especially in building facades, which form the first line of defense against environmental forces like fire hazards and structural vulnerabilities. The importance of safety by design cannot be overstated. Architects, designers, engineers, and builders hold the key to creating facades that are not just aesthetically pleasing, but also robust, sustainable, and safe for occupants. For the end users, occupants, and owners, understanding these aspects ensure peace of mind and a higher quality of life. We're honored to have with us today Mr. Rajan Govind, Director and Facade Plus Construction Tech Specialist from BES Consultants Private Limited, Mumbai, an internationally recognized firm offering state-of-the-art engineering, innovative design solutions, and value-driven services. Mr. Rajan brings 34 years of international experience in the facade industry, including 12 years at Arrow. With a background in structural engineering, he has worked across Asia, the Middle East, and Australia, delivering prestigious projects in both new builds and existing buildings. Known for his expertise in integrated facade designs, 3D design, complex engineering, and building integration, he has successfully led projects like The Park, Brigade Tech Garden, Pan Pacific Hotel Singapore, ASPTM Hospital Vietnam, and Wing Tower Cambodia. As a certified Singapore Green Mark manager, Mr. Rajan seamlessly integrates sustainable design principles from architectural and practical perspectives. Passionate about future technologies and innovation, he actively adopts cutting edge solutions to improve design and construction efficiency. A well respected figure in the regional facade industry, Mr. Rajan is recognized for delivering high quality and impactful work. Welcome, sir. We are thrilled to have you with us today. Without further ado, I will now pass it on over to you to begin your presentation. You may now please share your screen and present, sir. Over to you.
Thank you, Anvita, for introduction. And it's be a good pleasure to be part of this presentation. And thank you, Glass Academy organizers and everyone. And most importantly, I thank you for attendees who's taking out the time to be part of this technical sharing session. So I'll just share my screen and start presenting it. Just allow me for a few seconds. So I think this nice introduction is given by Anvita, so I don't have to introduce too much on. I can straight away jump into this session. I tried my best to show something safety by design, highlighting the safety aspects, especially for high-rise building facades. As we have been seeing, this trend in constructions going vertically is needed to maximize the urban space. And at the same time, we cannot forget the safety of the design. So something more practical aspects, I try to bring few technical sharing to the attendees. Just a few introduction to BES. We are about facade engineering, taking care of various type of developments. And we do works in our 3Ds. We are very passionate about geometries. We work on complex shapes, structures. Wind engineering, as we work on high-rise buildings, so we're very well aware of how the wind is impacting on high-rise tall buildings. And we have office in Singapore and Mumbai, those two offices, and we work from Far East to India and Africa. That's our market. So switching on to the topic for building facade, what we try to capture in this session is I try to capture as much as possible, focusing on the safety aspects. Good design, what is called a good design, and some life safety aspects. What is about fire safety specific to facades? I would try to show some standards, which is a local standard. How is it comparing to the other international standards? Yeah. So understanding the safety has several aspects. Safety means it's not just from structural engineering point of view. Safety also comes in many different forms. It's a human life safety. So the primary factor of safety, when we say safety, means the first thing we realize is structural engineering, which is driven by the wind forces, connection design, especially for facade, and it should be structurally robust. The design should be robust. And we also see a risk is falling object. There are things falling from the high-rise building is posing a risk to the pedestrians or occupants or the surroundings. And occupant safety, which is something about protecting the occupants, users, so that is built for the purpose. And another important aspect is fire safety. So fire safety, we are often hearing problems with the building fire, and sometimes it's also people has a perception of fire risk on the facades. And we try to also capture some of the weather protection. So how the facade is helping to protect the weather challenges. The first thing on the facade aspects, we all talk about structural engineering. The structural engineers know the major predominant force on the building is the wind. So wind is a natural forces, and it has a huge impact on the structures. So the better we understand the wind, the designers can do a better design. So sometimes wind is often see the wind is only happening on a high-rise tall building. So if you design like a low-rise building, single-story building, ground floor building, maybe it's okay. I can compromise design. The wind is not coming to the lower level, so which is not the case. Okay, so sorry for the noise. So the video clip is showing the impact of the design. I can just now mute this so I can replay this. You can see the wind is on the ground floor entrance of the building. So the things are get blown away. The doors are falling. The glass are breaking. So the phenomena of the wind is huge. So it doesn't matter. It's only for high-rise building. So it is on every building aspects of this. The wind also is creating a lot of other secondary impact on the building on various locations such as entrances, canopies on the entrance, roof, terrace, projection. So when the building, as we know, is a lot of projection, is attract a lot of wind, shadings, corners, large openings like refuge terraces. On high-rise buildings, we have a lot of balcony openings, double height spaces. So this give huge challenge for a designers to understand various aspects. And structural safety, wind engineering, generally there's two different approaches is followed. Uh, the primary approach is following the Indian standards as a codal based approach. You can see the code based approach will give a good understanding for a regular shape buildings, and you can see the wind forces corners are extremely high wind. As you can see, the wind corners are 1.4 times, 1.5 times of the middle of the building. And for complex shapes, we also use a simulation based approach. So simulation based approach is good for complex buildings where it can give a much better understanding the wind forces on various parts of the building. So wind forces on a complex building, simulation approach also is very well even referred by NBC. And structural safety, we should also take care of fixing and connection. So when we design for engineering, it is not just we have to design a glass or cladding and member. Safety of the connections is very important. So the facade elements is held by these brackets and fixings. So maybe the panels or glass, one piece of glass may fail, but bracket system fixing cannot fail. So there's a greater emphasis on fixings. As a general good principle is you should transfer the load directly. You should be structurally efficient, and it should design for a movements, rotation, all sorts of other impacts. Ease of fixing, it cannot be too complex for the person who is installing at the site, and ability to interface with the building much more cleaner manner so that it doesn't impact on architectural and designs. And so we talk about a lot of fixings and connections in the bracket, because in the facade is nothing but connecting various different materials together. So we always have a lot of different connections to deal with it. And this fixing and connection should be designed to take care of the tolerances, whether the concrete building or steel building, how much the building has the tolerance. The framing system and fixing should be designed to take care of the tolerances. there is always a tolerance. So it is not as we design, as we get in the site. So the fixing and designs detailing should be taken care. And especially for high-rise building, we face challenges of inter-story drift. So it's basically a building swaying due to maybe a seismic or due to the high wind. And there are design methodology and factors are design clearly given in like IS code 1893. And generally the sway we designed for a H over 500. H is the height of the individual floor, and 500. That's a factor of safety is taken care to design the joints. So the joints are, as the building is swaying this way, there is a joint movement has to be designed. So the high rise, especially high rise building, is not stiff. So it's a slender. The facade system should accommodate the building movements. The way the building movements happening due to seismic or due to the high wind has a various different modes of story drift happen. There's one type of mode, as you can see, the type mode is doing like a S curve pattern, and type 2 deformation is happening more of like a parallelogram way of drifting. So there are various different modes these panels should be designed, and the connections and the brackets should also be verified for these types of modes. And this movement not just giving impact of just a simple straightforward linear movements. The movements happening on the lateral means this way building moves, and also there's a vertical movements. So there's two different way we deal with the facade movement in the high-rise building. So there's movements where it starts with the thermal movement, interstory movement I just mentioned, a building sway, and there is a tolerances we should take care, and floor deflection. So when one floor is occupied, the other floor is not occupied, so there is a differential floor loads need to be designed, and a building torsion, especially for a slender building. And when we say vertical movement, that the movements are slightly different. So you have a thermal movement, differential live load, floor deflection, insulation tolerances, and creep and shrinkage, column shortening when the concrete structure has also vertical shortening effect. That all need to be taken care. In reality, when we design the curtain wall, the frames are designed something for horizontal movement. As you can see, this is a detail showing a typical high-rise building where it's using unitized curtain wall. The glass is fixed in the front, and the panels is allowing for a sideways movement. And the simulation on the right side, you can see this two male member and female member malins is opening and closing. So it's open and close. By when it is open and closed, there's a movement is happening around this area. So this is allowing building sway horizontal movement. And another movement we have just spoken about, vertical movement. When the building facade panels are put on the face of the building, when each slab is vertically moving in a differential load movement, where you can see the simulation on the right side, it is showing this much allowance should be given to design these systems. So you can see there's a vertical joint here. This is how it get constructed. So it's nothing really stiff on, especially the facade system on a high-rise building is very much flexible. It should adapt how the way the main building is behaving. So you have a lot of allowance for vertical movement and horizontal movement. Yeah. And because of the facade system also taking care of architectural design intention, we can't just detail like other structures we do, concrete or a steel building. So we need to take care of detail how it consistently shown as per the architecture, various ways we can do the designs, like a open joint or having a different expression, a capping expression. We should take care of these joints is aesthetically pleasing design. So then we move on to different aspects of falling dangers. So there always sometimes come in the news something is falling from the building due to the heavy wind or something. But as engineer, we don't just accept the fact of is falling due to heavy wind. It should be designed for that, supposed to be designed for any types of wind. So falling on any type of wind or extremely wind is really not acceptable. Falling danger generally things coming from the projection of the facade being maybe a windows or maybe a fin cappings, sunshade. There are so many attachments happening on the facade. So unfortunately, things are falling. Main aspects of falling windows we generally see on a high-rise building, especially in Mumbai. Every year monsoon, we see the windows are falling. Especially the windows are falling because of the hardware is not design is not appropriate for to suit that particular type of windows. We see these things are broken and is dangerously dangling in the building. It can fall anytime. These are like falling risk from high-rise building. There is a solution. So it is not just a risk because of the heavy wind. So if the hardwares are right, and sometimes we use a different type of hardware, smaller hardware or bigger hardware. It should be designed and engineered for that purpose. And there are other things can fall from the building, like a broken glass is falling from the building. The broken glass will break, as we know all. But we have to consider when it breaks, what happened. So it should be safe in a place, or it should fall somewhere which has no risk to pedestrian or occupants. So that's the purpose of the design. And you can see the clip on the right side. There's a laminated glass is falling from the edge of the building. So it is still using a laminated glass. It's supposed not to fall from this level. It should be staying in this place, but it is fallen off. So there is an inherent problem with the design, or when after the glass breaks, it's not able to hold. So we call post-breakage behavior. So the post-breakage behavior should be considered. And areas we see the high risk of things falling, and it imposed dangerous to the occupants, such as overhead glazing. This is not necessary for a high-rise building. This could happen anywhere. This particular picture has taken somewhere in the airport area, where we have seen the glasses on the sloping glazing. If it fall, they have not used a laminated safety glass. So if the glass breaks, it should not fall. So if should not fall means they have to use a safety glass. So the glass is available, but they have not used the right glass. So there's a sloping glass. If the glass breaks, so it's just showering around this area where pedestrians or public are using this space. So we need to see the risk of falling, and what is the impact of life safety. Not just a glass. Things could fall off from the building. Some video clips or this is taken from somewhere else, where we often see whenever there is a heavy wind. Now, due to the weather change, we know this heavy wind happening, this phenomena happening frequently. Before we used to have this heavy wind maybe every 3 years or 5 years. Now we can almost see every years we get a wind happening. Not just one city, we can see is everywhere. And just replace the video, we can see that things are falling because it's not fixed properly. It's not designed. It's not implemented properly. Like a lot of this ACP or a cladding panel is very widely used. Sometimes it's not engineered, it's not detailed. There's not enough attention. The engineers sometimes they just think about only the panel thickness. So I use this thickness is okay, but he's not considering how stiff it is. And we could see this falling danger mostly happening on these panels, cladding panels, being ACP or cladding, or mostly on a cladding panels. This picture is taken somewhere, maybe from the airport. There is not enough attention is given. Like, how do we detail this? How do we detail this? There's not enough attention is given. This cladding panel should be fixed properly. There's no fixing information. It's not stiff enough to be in this place. And when the wind is blowing, especially the corners, fascia, you'll have extremely heavy wind. These small pieces flying in the air and posing a significant risk to the occupants. And these are like missed out design or not taken care of adequate care in the design. If you are taking care of this much care, any amount of wind pressure, extreme wind, even like 240 kilometer, 300 kilometer, it's supposed to be standing in its place. It's not supposed to fly. Problem is not been designed, it's not been implemented. As you can see the panels, there should be enough stiffener here. It should have a fold. All the corners should be stiff enough. There are so much detail should be done properly. Then it will stand there for any amount of wind forces. So same, I'm continuing with this because we see a lot of falling danger, mainly especially happening on this cladding panels, like roofing area, where this picture is showing of somewhere in the terrace area. Usually things get blown away and falling off the road. You can see the sheets are not fixed properly. It's supposed to be engineered. There should be some framing behind to hold the sheet. But these sheets are just laid there and just screwed to somewhere and it start falling. So the panels are not secure. That's a problem with this kind of fixings. And the designer should be taking care of this anchorages, especially in the facade. We use with the different types of anchors. Various substrate. So sometime maybe RC wall, brickwork, hollow brick, lightweight brick. So there's always solution available. So the engineers or designers should be mindful of using a right anchors, understand what is a supporting structure. It is not just one solution. Every building is different. So the engineers, designers should take care of different types of fixings. Other aspects of risk from occupant perspective, for those occupant inside the building, there is a risk of they are falling out. So often we see there's windows at the low level. It's supposed to have some guardrail or something, or there should be some restrictor which is allowing a restricted opening, which is not there. So these all like a risk of falling, which is not complying to the standards. And a standard always gives some height, so supposed to be some minimum height, and all the low level glazing should be protected with some rails. Whenever the windows are opening, they should have a restrictor here, so you cannot open fully. You can only open to standard say 75 to 120 millimeter clear opening, so that it is safe to open and nothing is falling from the buildings. The glazing which is happening on the low level has a human impact below the sill level. So the sill level, say maybe 1 meter from the floor level, all the glazing below the sill level should comply to some safety standards. Especially NBC 2016 Part 6 Section 8 is meant for a glazing, has given a table which I'll show you on a further slides. It has given a various criteria. What is the glass type should be used? How do you protect the glass which is subjected to human impact? So basically, the glasses should use a safety glass on the low level areas. And railing. So railing is a key component of the building where sometime often ignored. Minimum height is not followed, or where should I measure the height? So there's always the height should be measured from where you can access. So it is not from the floor level. There's always a ledge sometime, or maybe a small curb wall or toe wall. So the height should be mentioned, referred from highest point of access. So child can climb over, somebody can stand on it. So is it enough height to cover this so that is protecting the occupant? So that height of railing should be considered from the point of highest point of access, not just from the floor level. We could also see a lot of things are dangerously risk of glazing, because architectural design is one thing, but as an engineer designer, whenever they design such thing, they should take care. It may looks good, and there is nothing wrong with the design as long as it's implemented properly. So we can see very widely used this frameless railing on a buildings where sometimes is anchorages things are failed. So you can see the video clips on this particular building has all the anchor points are failed. So these are significantly risk to the occupants and those around the area, like a pedestrians. So they should give enough attention to the fixing, not just to design. How is it implemented on the site? We sometimes see the fixing, they show concrete, or maybe they're showing something upstand, or mortar filling is not the structural upstand. The whole channel is just a flip because it's not anchored properly. This is a table I have mentioned before, like NBC Section 8, 2016 Section 8 has a table 30. This is a very important table for fall prevention, occupant safety. what is the correct type of glazing to be used. So there are so many things covered on this table. And it also covered to like a residential facade, commercial facade, various different types of facade. So very important table. It is if the design is compliance to this table, it is, we can say, it is complying to the fall prevention for occupant and pedestrians for all other aspects. We now move on to the fire aspects. So the fire aspects where I give a little bit introduction. Whenever the fire, often facade is get blamed. So it's not true, but we need to see the impact of the fire on the building. So there are various news throughout the world. We have been seeing the buildings is fire, mainly on the cladding material. So there's a lot of cladding material used, especially is done like 20 years before, 30 years before, or sometime even done recent building. They don't use compliance material. They use non-compliance material. So that's pose a huge risk of this cladding fire on the building. So this completely burned out building. You can see they have not used a proper cladding, fire rated. There's a fire rated grade of composite panels, and it immediately spread throughout the building because it doesn't hold the fire. It vertically spread. So there's always solution is there. So you have a solution which also works, and there's a solution which has no safety. So when the cladding material should comply to a certain standard, these are the standards, internationally well recognized standards. Whenever we see the material, we look for this standard. If this material is compliant to this standard, like EN 13501, if it is a class BS1, or part 6 be a standard class 1, means the material is good to use for external. And especially for a cladding material, we also have fire rated panel or non-fire rated panel. The panels, what you can see, there's a black color core is a highly flammable core, and this we call fire rated FR grade composite panel as a white color core. So we can differentiate this. There are solutions available, so someone has to be mindful of using a correct material. And we often do the testing, evaluate the risk, not just relying on the certificate and standards. So, so this is one risk study we have done for a building on using existing, because a lot of existing buildings using this ACB cladding materials, not necessarily everything is compliance material. So sometimes we see the risk and suggest the client. Sometimes we go for a testing. What is the risk associated with the existing building? And what is a fire spread or smoke spread? Do they have to replace, or they can retain, or they can do some mitigation measures? So we have to evaluate the application where we are applying. And there are a little bit of detail about other detail I will go, especially for detailing of the facade. So we spoke about materials, so use the right material, so it's fire resistant material. Then we can go further a little bit about detailing on a facade. So this detail about speaking about fire separation, whenever we have this curtain wall being a residential, or mostly this is predominant on a commercial building, the curtain wall going out of the slab, and there's a edge perimeter of the slab, there's always a gap here. That gap need to be sealed. This is explained in this image. If any fire happening on the lower floor, it should not spread to the upper floor. So that is called fire separation detail or compartment the detail. So it is not spreading above. So for that purpose, this detail should comply with the smoke seal and fire seal as per NBC 2016 Part 4, Class 3 4 10 2. So if somebody is detailing this and is complying this, there is no issue of fire spreading through vertical spread from one floor to another floor. In continuation of the same detail, this is the detail, and if the detail is done correctly, and there's no way the fire can spread from one floor to another floor. So it's compartmentalized. This actual detail, there are details should be followed, it should be sealed. And we often go and test this detail on actual site, whether is detail is working, it is still posing a risk. So this is a finished detail, it will look like this. So if anything fire below is not really coming to this floor, there's a fire separation detail. So this video clip is showing how it's tested on the actual building. There's a smoke is spread on the bottom floor. We have to make sure it's not going above floor. So this video, you can see this is one as a failed test. The smoke is coming various places because it's not sealed properly. Yeah. So the other aspects of fire is we have also we spoke about fire. Now what about smoke? When fire, there's also huge smoke is accumulating on the floor. We need to make sure the smoke is evacuated. For that, again, the code has given various options. So you need to do some windows. There are two types of fire evacuation. So there is one window which is called a smoke vent. What you see on this, when smoke is happening, if these windows are motorized connected to the building maintenance system, it open automatically, the smoke is evacuating. And there is also side open windows. This is basically a fireman access window. The fireman, these windows can be opened from outside. This is especially given for high rises in Mumbai. So the firemen open the window and they evacuate. There's also another way of this type of a breakable windows. So this is widely used and is recommended in NBC. So we give a openable windows, breakable windows, so the occupants or the firemen can break open and they can evacuate. So smoke can evacuate. So this all options is given. So if some design is done, follow these principles, there's no risk of fire. We move on to material. So the material and durability should be taken care so that the facade has a long lasting, not just what we see outside. There are things gone inside, connections, bracket. We have to make sure that it's not visible, but we have to make sure it's not posing a significant risk. The detailing, sometimes there's a lot of mechanical and equipment sometimes cause problem with the facade. So we need to make sure there is nothing water running off. The detailing should be done on various locations of the facade, especially if you have a projections, it should be detailed so that the water runoff can be minimized and it will extend the facade lifespan. And there's various ways we can protect the facade system or material or components like hard dip galvanized for all the steel structures. And whenever there is a good finishing is needed, we need to give a paint system. So hard dip galvanized is the best form of protection. And we can also have a 3-coat architectural finishes wherever the system or members are exposed. So I'll just say something about the weather aspect is causing a huge challenge to occupants is because every year we are seeing this increasingly the rainfall is getting higher and the intensity is higher and it's all wind driven rain, especially for high rise structures. We have a challenge of wind driven rain. This is just showing the intensity of the rain when it comes to the wind. Then that's challenges to the facade. So this couple of slides, I'll try to show you the challenges on the facade, being especially the leakage problem we often see due to the heavy rainfall and wind-driven rains. So there are a lot of detailing should be taken care. Sometime maybe structural civil works detailing is done badly. Water may be leaking from the concrete structure, not from the facades. And this partly may be a design problems or not implemented properly or it's not detailed enough. And yes, and it has a serious damages to the interior and the building values is diminished drastically. So when we have a leaking facade, the water is leaking and then it will spoil the interiors. And then we need to speak about the residential, sorry, not residential facade, maintenance. Any facade, we need to make sure it is maintainable, cleanable, and it has to be good looking for her extended life. If it is not able to maintain, clean something, defect, if it's not fixing, then it poses dangerous of a safety risk. So any designer should have a responsibility of able to maintain and clean it. Various ways it can be cleaned, especially if you have a facade with a lot of projections. There's a system where available where It has an extended arm and sophisticated system for cleaning. This slides, I'll try to show something about maintenance access, not just for a cleaning. There's always sometime ignored by the designers. How do they maintain the building? How do the air condition fixed? How they going to service this building after it's completed? So I just took some inspirational videos. But these all are like forgotten problem or never thought about it, and it has a negative impact on the building aesthetics, overall values, and it's not a good design. And most importantly, it poses dangerous to the pedestrians. We can see the air condition is just fixed on the ledges. The picture on the right side, you can see is enough thoughts as given, so it's safe and it's properly designed. Just coming to the almost end of the slides. So there is few points I would touch base on. Myths of the facade. Often we see facades causing problem, fire risk, and other things. So we can see this is just a news I picked up from the latest news. There's a fire on the building, and you can see sometimes the glass facade is causing fire. Smoke is not able to evacuate. When you see in detail, this is actually a clip from the website. So there's a comment showing here is major drawbacks on glass facade building is the smoke does not have an outlet, and it is unnoticed. But then again, finally, what we found is real fact is the main active fire protection system, sprinkler system, is not working. So it's not that the facade is getting unfortunately blamed. It's a system that active fire fighting system is not working. And there's another myth of glass facade is going to cause excessive heat. We should not use the glasses on, especially tropical climate. This is a picture showing on the right is a IGBC Platinum. That's the highest rating we can get. Actual building name is given, and it has all glass facade. The building has achieved a Platinum highest rating. So the fact is, if the design is taken care, the facade is, there are various high performance material, option is there. If that's enough thought is given, there's always a better solution available. So thank you.
Thank you, sir. This was an insightful and comprehensive presentation on high-rise building facades, safety by design. Your presentation provided immense value by decoding the critical aspects of facade safety, including good design principles, life safety considerations, fire safety specifics to facade, international standards in the latest NBC and IS publications. It was enlightening to see how thoughtful design, coupled with the adherence to safety codes and innovative practices, can create facade systems that are not only visually striking, but also safe, sustainable, and durable. We truly appreciate the depth of knowledge and the real world issues or examples you shared today, offering our audience actionable insights to integrate safety as a core element in their projects. So, to further our understanding, we would like to take this opportunity to ask you a few questions.
Sure, yeah.
The first question is what you already spoke about in your previous slides about some of the common misconceptions or myths. So one of the most common myths around high-rise buildings is that, like you mentioned, glass facades are unsafe, especially during fire incidents or structural failures. Could you elaborate on how glass, when designed and integrated correctly, can actually enhance safety, and why the real issue often lies in overlooking essential design?
Yes, I think it's the most widely come in the news. Any building start firing, the first thing, unfortunately, they blame is a glass facade. So I think the few slides I have shown the glass facade, there is an issue of smoke is spreading from one floor to another floor, and then the facade itself is has to be designed for the ventilation. In terms of fire, there's always smoke. The smoke has to be evacuated, and that's taken care with the ventilation and perimeter sealing, what is seen on the building. But the building firefighting system is a heart of the fire prevention system. That should be there in place. So unfortunately, all this news we have seen, eventually, if we go in detail, the system was not working. And we can see not only in India, throughout the world, there are many buildings. This fire accident happened. There's always that their active fire safety was not working. But facade, there is nothing negative about the glass. Glass is not a combustible material, but it doesn't enhance the fire. Anything on the facade doesn't enhance the fire. So that's a positive impact on the fire.
All right. That's very well put, sir. So moving on, there's often a perception that high-rise buildings increase energy consumption. So how do advancements in facade technologies like double glazing, low E-glass, or ventilated facades address this issue while ensuring safety and sustainability?
Yes, glass is a sustainable material because we use just a 6 mm of glass, so that embodied energy from the glass is very, very low. So that's really a very big positive point of material. If you see the overall building material, the glass is one of the lowest energy consumed product, and it gives us so much of benefit. So as everyone know, glass is an amazing material. We need to use that material for not only external, for internal various aspects. And in terms of sustainability, especially the glass engineering last few years is evolving with a lot of new products, high performance material, the coating. Now we have the glass coating. We get shading coefficient as low as like a 0.2. It was not there before. So there is so much of advancement of glass technologies improving. Performance has greatly improved. We can have even 100% glass box building. It is still, I shown you, as a platinum rated building, not only in India, it's getting built all over the world. So this perception, I think, is changing recently, not recently, last a few, 1 decade itself, we can see a major shift on glass materials. Yeah.
Great, sir. So this brings me to the last question. As high-rise buildings increasingly embrace complex geometries and curved forms, like you showed a few examples, facade safety becomes even more challenging the complexer we go. So what innovations in glass and facade engineering are helping architects achieve such bold designs without compromising on safety or structure?
Yes, I think we are now in the evolution of fascinating design, code design, geometry, as everyone will work with the latest technology tools, computers. So there are various interesting facade geometry is coming from the architectural inspirational. And that especially the glazing industry, facade industry is adapting, and they are giving much more confident. Now the trend is using the large panel, extremely large panels, like jumbo size glass, we call 6 meter by 2 meter, 2.5 meters, really unimaginable these sizes before. So, and to complement this, the processing industry, the contractor industry, the whole industry is developing, not just a glass. So we can see the buildings is really getting implemented with the complex geometry. They can able to bend the glass. They can do extremely high performance glass and high performance lamination using like Sentry glass and different performance material, where the glass is safety is further enhanced, not concerned with the geometry sizes. Because of this, I think that the confident level with the completed projects is built projects is giving confident to architects, designers. There's no really limitation. So whatever based on your imagination, it can be built.
Yes, definitely, absolutely. So this brings us to the end of the webinar today, and thank you very much, sir, for your time and expertly guiding us through this complex world of facade safety in high-rise buildings. Your insights into design principles, material choices, occupant protection, fire safety, structural integrity, sustainability, and the role of glass in high-rise design has given us invaluable knowledge to apply in our own work. So on behalf of Glass Academy and Ethos Empowers, we extend our heartfelt thanks to you, sir. Thank you very much.
Thank you. Thank you for the opportunity. I hope it was useful. Thank you.